Geosequestration, along with renewable energy, switching to less carbon-intensive fuels and energy efficiency, offers the best solution for addressing the issues of global warming. Carbon dioxide, or CO2, resulting from the production of energy is the world's most common greenhouse gas. Geosequestration, the safe storage of CO2 deep within the Earth's subsurface, will play an important role in reducing carbon dioxide emissions. It is a proven technology that the oil and gas industry has used for a number of years. The challenge now around the world is to build on past experience and to develop opportunities to apply the technology. With this in mind, Australia's first geosequestration project, the CO2CRC Otway project in southwestern Victoria, is playing an important role in demonstrating the technical and environmental benefits of the technology to the world and preparing the way to extend its effective application.
What we'll have is probably the most comprehensive monitoring program for stored carbon dioxide anywhere in the world. It'll also be one of the largest pilot projects in the world. So it's a very, very significant project even by world standards, and we're having a number of international groups who will be working with us as part of this experiment. So it'll be the first real test of geosequestration under Australian conditions.
We've got a ready source of natural CO2 nearby, so we're able to pipe this CO2 from 2 kilometres to the north to this location here. We're currently drilling our injection well. We're going to inject it here, and it's got a nice proven trap about half a kilometre to the west where it can accumulate. The most important thing about storing CO2 is that you've got a nice thick impermeable rock, which we call a seal rock. In here is the Belfast mudstone, which is around 500 metres thick, so it's very, very difficult for CO2 to move vertically through that. As well as that, under that we've got a nice permeable rock, a sandstone rock, which CO2 can move through very nicely.
There are several types of geological formations that can be used to store CO2 underground. The Otway Basin has been chosen as a suitable site for this CO2CRC project, as it has a ready source of naturally occurring CO2 that has been stored within the rocks for millions of years and formations suitable for long-term storage. Currently, we're exploring the storage of CO2 combined with a small amount of natural gas in the Warri C formation, a depleted natural gas reservoir. The CO2 will be compressed into a supercritical or fluid-like state and have a density similar to water. The CO2 then takes up less space when stored. Once transported by pipeline and injected into the depleted gas field or reservoir at a depth of 2,000 metres, the subsurface pressure maintains the CO2 as a fluid. Warri C is very good for geosequestration, as the porous sandstone has safely stored natural gas beneath the earth for millions of years. Several different trapping mechanisms hold the CO2 within the reservoir. A naturally occurring impervious seal above the sandstone formation traps the CO2. Sealing faults and anticlines or folds in the Earth's strata can also trap the gas. Assuring the community, government regulators and industry that the geosequestration project is running according to plan is a high priority for CO2CRC. This is being achieved through one of the world's most comprehensive monitoring programs, which is being conducted before, during and after the injection of CO2 into the storage reservoir. Deep subsurface monitoring of the reservoir will complement air, soil and groundwater monitoring. CO2CRC's Naylor 1 well is dedicated to monitoring the physical and chemical makeup of the reservoir. Through geochemical monitoring, researchers will track the movement of CO2 in the reservoir and confirm that the behaviour of the injected gas is as expected. Geophysical monitoring will use sound waves to build a three-dimensional picture of the reservoir and the CO2 contained within it. Sound detectors, called geophones in Naylor 1, will detect any changes in the formations during and following injection. The great benefit of geosequestration is that it can make large reductions in CO2 emissions while retaining the use of fossil fuel for baseload power. The CO2CRC Otway project plays an important role in demonstrating this technology to communities, industry and governments worldwide. The CO2CRC Otway project is key to demonstrating that geosequestration is a sustainable way of decreasing CO2 emissions.